Hello, welcome to the course of satellite. So today we are going to discuss about the radio waves. So here in this chapter we are going to discuss about the radio waves, then the mode of propagation and lastly the propagation techniques. So here in this chapter let's discuss about the very first, that is the radio waves. So here the frequency of radio waves is a critical factor in carrying the space communication, and here a radio wave propagates from the earth's surface to the outer space using high frequency, and the high frequencies is enough to penetrate the ionosphere. Here ionosphere is the ionized region extended from about 15 km to roughly 400 km above the surface of earth, and here the various regions in the ionospheres are designated by D, E and F in order of increasing altitude, and these different layers act as reflector or absorber to radio waves at frequencies below 30 MHz, and here the space communication is not possible. So here the type of propagation. Let's discuss about these. So here the type of radio wave propagation mode are: the first one is ground wave propagation. Here in ground wave propagation we use the frequency below ionospheric penetration frequency, and here wave propagate along the earth's surface, and it is used for broadcasting and communication services such as AM broadcast band, amateur radio, radio navigation and land mobile services. Here the three components of ground wave propagation are direct wave, ground reflected wave and the surface wave. Second mode is the terrestrial propagation mode. Here it is using a frequency below 300 MHz, and here wave propagate toward and return from the ionosphere. So here it is also known as the ionosphere or the sky wave mode. And here these waves are used for commercial FM and very high frequency television band, aeronautical and marine mobile services. Next mode is troposphere or forward scattered wave. Here it is using a frequency above 30 MHz and up to 3 GHz, and it is generated by scattering of energy from diffractive index of the troposphere, and these signals are used for the long distance communication. Next mode is the direct propagation mode, and here it is using a frequency above ionospheric penetration frequency, and here the wave propagates as the line of sight propagation, and it is used for terrestrial radio relay communication and broadcasting services. Now the radio wave propagation mechanism. So there are different mechanisms. Let's discuss about these one by one. The first one is the absorption. So here absorption, it is a reduction in the amplitude of a radio wave. Next is scattering. So scattering is a process in which the energy of a radio wave is dispersed in the other direction, and here the scattering is due to interaction with inhomogeneities in the propagation medium. Next is refraction. Refraction is a change in the direction of propagation of radio wave, and here it results from the spatial variation of refractive index of the medium. Next is diffraction. Diffraction is a change in the direction of propagation of a radio wave, and it is result from the presence of an obstacle, a restricted aperture or the other object in the medium. And the next one is the multi-path propagation mechanism. Here this propagation condition occurred in transmitted radio wave while reaching the receiving antenna by two or more propagation paths. Here multipath can result from refractive index irregularities in the troposphere or ionosphere, or from structural and terrain scattering on the earth's surface. Next is the fading. So fading is the variation of amplitude of a radio wave, and then is scintillation. So here in scintillation, it is occurred as rapid fluctuation of the amplitude and the phase of a radio wave with respect to the time. So here the scintillation is caused by change in transmission path with time. And here the term fading and scintillations are interchangeable. However, the fading is usually used to describe slower time variation on the order of seconds or minute, whereas the scintillation refer to the more rapid variation on the order of fraction of seconds in duration. And the last one is frequency dispersion. So here the frequency dispersion is the change in the frequency and phase component across the bandwidth of radio wave, and it is caused by a dispersive medium. And here it is also caused by small scale irregularities in the transmission path. So this is all about the radio wave propagation mechanisms. Next is the radio noise. So here radio noise are introduced in the transmission path of a satellite communication system from both natural and human induced sources. So natural sources are of two types, that is terrestrial origin and extraterrestrial origin. So here these are the type from where the natural terrestrial sources and the natural extraterrestrial sources noises are coming. So here the natural terrestrial sources include like emission from atmospheric gases like oxygen and water vapor. Next is emission from hydrometeors, that is rain and cloud. Then is radiation from lightning discharges and re-radiation from the ground and obstruction with the antenna beam. So these are all natural terrestrial sources. Next is natural extraterrestrial sources, that is cosmic background radiation, solar and lunar radiation, and radiation from celestial radio sources. So these are the type of extraterrestrial sources that are inducing the radio noises. Next is the human induced sources. So here the human induced noise sources are like unintended radiation from electrical machinery like electrical and electronic equipment, and second one is the power transmission line from the internal combustion engine ignition and from the emission from other communication system. So these are all human induced radio noise sources. So this is all about the satellite. Satellite radio waves. Thank you.